All right, so first question we're going to take a look at is a concentration problem. So we're starting with an 80-ounce solution, and out of the 80 ounces, 40% is acid. We're going to pour acid into it until we get the concentration from 40% up to 65%. So I want to know how much acid is it going to take to do that. Okay, so first step, we need a formula for the concentration as a function of how much acid we're pouring into the mixture. Okay, so formula for concentration. What goes in the top of the fraction? Just in words. Yeah?
Is the amount of acid over the total?
Yep, perfect, over the total liquid. So let's start with the amount of acid. We have 80 ounces we're starting with, but not all of it is acid, only 40% of it is. So how do we figure out how many ounces of acid are actually in the 80 ounces of liquid? Yeah.
You multiply 80 by 0.4.
Okay, so we're going to do 80 times 0.4, and that's going to give us, what, 32? Yep, so we have 32 ounces of acid, plus how much acid are we pouring in? Yeah, yep, we're going to pour in X ounces. So that's the amount of acid. Now the total amount of liquid. How much liquid did we start with? Yep. 80. And how much liquid are we adding to that? X. So that's a formula for the concentration as a function of X. So now, if I want to figure out when I get to 65%, what would be my next step? Yep.
C of x equals 0.65.
Okay, so we can do it algebraically. We can let C of x equal 0.65, and then we can solve it. Or
Graph it.
we could do it graphically.
Graph it and then put that answer and C and 0.65.
0.65. Do you guys want to see it graphically or algebraically? Which way?
Could you do both?
Could you do both and use
Both?
the graph as the check?
To double check? Okay. So let's do 0.65. That's my concentration. So I'm setting it equal to what they told me they want. And the formula is 32 plus X over 80 plus X. So first step is to multiply each side by 80 plus X. When you do that, the 80 plus X is gone on the right, and it's now on the left. We will distribute. I'm not sure what 0.65 times 80 is. 52 plus 0.65X. Okay, now let's finish solving for X. What would be my next step? Yeah, please.
Subtract 32 and divide by 0.65.
Okay, so subtract the 32, that's good. What else would we do?
Oh, subtract by 0.65x.
Yep, subtract 0.65x. 52 minus 32 leaves me with 20. And what's 1x minus 0.65x? 0.35x. Okay. And what's the last step to get x by itself?
Divide again.
Yep, divide by
0.35.
0.35. And this will tell us how much acid we have to add to the mixture. So 20 divided by 0.35. So we need 57.1 ounces. That's how much we need to add. All right. And now you wanted to see it with the graph as well? Okay. So graph, same idea, except that'll be y1, that'll be y2, And we're going to set them equal graphically, which means we're going to look for where they do what? Intersect. All right, so let's put in, what was it, 32 plus x. 32 plus x divided by 80 plus x. Put in 0.65. Okay, set your window. We're not going to be adding a negative amount. We don't know what the upper limit is. We know we need 57 ounces because we already did it. Let's say we went up to 150. The minimum, well, we can't have a negative concentration, and you can't have a concentration higher than 1 if you're looking at it as a decimal. It's always between 0 and 1. Our concentration can't go any lower than actually 40%, because that's what we started with. Let's find the intersection point. And we get 57.14, which is exactly what we got algebraically. Any questions on that? Great. The next question we're going to look at is graphing a rational function. These are the 5 things that you generally want to find. The first 3 have to find. Intercepts, nice to find, not as necessary. Okay. So to find the vertical asymptotes, first thing we got to do is rewrite that. What part of that do we need to rewrite to make the vertical asymptotes easier to figure out?
Denominator factor.
Yeah, let's factor the denominator. And anybody tell me how the denominator is going to factor? Yeah.
X minus 3, x plus 1.
X minus 3. And what was the other one you said?
X plus 1.
Okay, let's check it. X squared plus x minus 3. Yep, looks good to me. Okay, are we going to have vertical asymptotes, holes, or both in this one? Oh, Jake, what do you think?
I don't know.
Not sure? Well, if we were going to have holes, what would have to happen? Yeah?
You would need a common factor.
We would need common factors, and we don't have any common factors. So there are no holes in this graph, which means that any undefined values are asymptotes, vertical. How many vertical asymptotes do we have in this one? Yeah.
2.
Yep, we have 2. And what are the 2 values that would give me vertical asymptotes in this one? Yeah.
3 negative.
3 and negative 1. Okay, so we've got those. We'll graph those in a minute. Let's do the EBM. So for the EBM, go back to the original problem. Don't look at the factored one. What's my EBM going to be when I simplify it as much as possible? Yeah, it's going to be 1 over x. It's x over x squared, which is 1 over x. Now, let x approach infinity, and that's your horizontal asymptote. What happens to this fraction as x approaches infinity? Yeah,
It's closer to 0.
gets closer to 0. So my horizontal asymptote is y equals 0. Okay, let's graph all those. So we've got vertical asymptotes at, let's do 3 and negative 1, and a horizontal at 0. So let's put that at 0. Let's put that at 3 and negative 1. All right, so that's going to give us some boundaries. What kind of asymptote can we never cross? Yeah.
Vertical axis.
Vertical. You cannot cross the vertical, but you can cross the horizontal, usually in the middle section. Okay, let's finish up with our intercepts. Okay, x-intercept. That's when you let y equal 0. Right? So y would be on the left side. If you set your fraction equal to 0 and solve it, what would you get for x? But Savannah, what do you think? If you set that fraction equal to 0 and solve, how can a fraction come out to 0? Remind us, how does a fraction come out to 0 when you do division? Yeah.
If the denominator is 0.
If the denominator is 0, that's undefined. Yeah, you can't divide by 0. Yeah.
If the numerator is 0.
Right. If the numerator is 0, then your entire fraction is 0. So what would make the numerator 0, which would make the entire fraction 0? Travis? 2. So that is your x-intercept. X-intercept is going to be at 2. Okay, y-intercept, that's different. You don't plug 0 in for y, you plug 0 in for x. If we plug in 0 for x, what do we get in the top? So the top is x minus 2. If you plug in 0 for x, you get negative 2. So we get negative 2 over, and what if you plug 0 into the bottom? What do you get? Negative 3. So your y-intercept is 2/3. 2/3. All right, so now we need to check what's happening near each asymptote. To do that, easiest way is to put it in on the calculator and then use the table. Okay, so we already have everything typed in. Let's start with the asymptote on the left. What would be a number that's a little bit smaller than -1 that I could check? Yeah. Negative, a little bit smaller than -1 is what? Well, we can try it. -99. Like that. So we're looking for a number that's smaller than -1. So think, use your number line. I want something like right there. That's smaller than -1. Yeah, that's a good value to check. -1.001. Okay, we are at -7,500. So that means we are way down on the graph. Now we want to check a value on that side of -1. Okay, just to the right of it. What would be a value that's just a little bigger than -1? Yeah.
Negative 0.99.
Yep. So let's try -0.999. So you're up at 7,500. So way up here. Okay, now we'll do the same thing for the other vertical. That's at 3. What's a value that's just a little bit smaller than 3? That we could check? Yeah.
2.9.
Yeah. So we're just checking to see what happens as we get close to 3 from each side. So as you approach from the left, you're at negative infinity. And then look at what happens as you approach from the right. So pick a value that's bigger. You're at positive infinity. I would also find another x value in this upper right area. What would be another good x value we could do? Just to get one more piece of information. Try
6.
Sure, let's try 6. So when x is 6, we're at 0.2. So 1, 2, 3, 4, 5, 6. Just barely above the line. And what would be a good value we could check in the lower left area? Oh, Alex, what can we check there?
-2.
-2? Yeah, we could check that. It's probably still going to be kind of far. Let's see, -2 is -0.8. So yeah, that's actually good. -2, -0.8. Oh, right there. All right, so now we're going to sketch what happens. Every section is going to be curved. We can only cross horizontals, and it's only going to happen in the middle section. So, draw your sketch. That piece curves down. Yeah, you all set?
Yeah, thank you.
You're welcome. This piece over here is going to curve like that, and the piece in the middle is going to do something kind of like that. I didn't do a great job in the middle. That's better. Now, some of those sections got a little bit steep, so when we try to graph it, it may not do a great job with it. It might look like it just stops all of a sudden. Oh, it handled that actually okay. And that's your graph. Any questions on how to sketch a rational function? Okay. All right, so next what we're going to look at is solving a system. This one is complicated enough that algebraically might turn out to be pretty difficult, so we're going to do it graphically. So we've already graphed both our equations, and once we graph them, what are we looking for? Yeah.
2 solutions, because
What are you looking at that tells you that?
intercepts, 2 intercepts.
You're looking for, sorry.
Intercepts?
Yeah. So technically that means where it crosses the axes. We're not looking for intercepts. We're looking for, yeah? Intersections. So where graphs cross each other, not where they cross axes. So we're looking for where they cross, and how many times do we think those graphs cross?
Twice.
Twice. All right, so let's look at it.
Is that 2, 3 times?
Yeah, it looks like it's going to be 3 times. So we're definitely going to have to zoom in carefully and check that other part out, the vertex of the parabola. But we can definitely do the one on the right. So we get our first answer. X is 3.41, Y is 6.657. Make sure you give the X and the Y value when you solve the system. Okay. Now, I can probably do this without zooming in. It looks like there's 2 answers. If you want to see it better, you could zoom in, but I don't think I need to. Okay, I got another intersection point right there. So 5.59 comma negative 4.66. And the other one, we're just going to have to move our cursor a little to the other side. Okay, so what's happening with that answer? What's my x value for that answer? Please don't say 1.438 e to the minus
Now
14.
there's 14 zeros until it's like 1438.
Yeah, so that's basically what?
0.
0. All right, so it probably is 0. The calculator just can't figure that out. So it's 0, -5. That's what it looks like. Right? And, oh, I think I had adjusted this too. Sorry, I didn't write down the adjusted problem. We could verify that it's 0, -5, because if you plug 0 in to the bottom one, you get -5. And if you plug 0 in for x in the top one, you also get -5. So it is 0, -5. And the other two, those are just not nice answers. So we would want to have to figure them out the way we just did graphically. Yes?
So tomorrow, if it's like says solve like a system of equations, then it would just be you can use a calculator as well as just solve if you want to. Like there wouldn't be one that is strictly algebraically.
I don't think for this, not if it's this difficult, no, because you really, I don't know if you could do that algebraically very easily, because it's a cubic and it doesn't look like, well, we did get one nice answer out of it, so maybe you would have gotten lucky and it would have, rational root theorem would have helped us somehow. But generally with this system, you're going to graph it and find the intersections. Okay, so this one they want us to describe the transformations, but it's not set up properly. Right? We've got to do synthetic or long division to make it so we can figure out the transformations. Let's do synthetic, because that is faster. What would go on the outside if I'm going to do synthetic division? Yeah.
-3.
Yep, -3. And the inside? Yeah. 4, -5. So bring down the 4. -3 times 4 gives me -12. And when we add up -5 and -12, we get -17. Okay, so remember how you write your answer after you do division. It's quotient plus remainder over divisor. But in this case, my remainder is negative. So quotient minus remainder over my original denominator. Okay, so that's almost the way we want it. We generally put the vertical shift at the end, and we put the vertical stretch in the front. So we would want to write this if you wanted exactly like I showed in class. You'd want -17 times 1 over x plus 3 plus 4. That's really breaking it down so you can see every single step separately. Okay, we're always comparing the function that I give you to the parent function. This is the parent function, 1 over x. So I want to know what I would have to do to this to change it into that. Okay. First thing is, how many transformations would it take to change the parent function into that one? Yeah?
4.
Yep, it would take 4. Can you tell me what number you would focus on first?
Shift.
So what number are you looking at?
X plus 3, so 3.
Okay, we do want to look at the plus 3. What does the plus 3 do?
Horizontal, not horizontal.
And we got to be a little more specific than just horizontal.
Shift, left 3.
Left 3. Yep. You actually don't have to say horizontal. If you just say shift left 3, that's good enough. Okay, so we took care of the 3, plus 3. What's the next thing that we look at there? Yeah.
Negative 17.
That's two things. We want to look at one of those. Anybody know which one we want to look at? Yep.
The 17.
The 17, yeah. What's the 17 do? You're multiplying by 17 in front.
Vertical stretch.
By how much?
17.
Yes, so it's a vertical stretch by a factor of 17. All right, took care of the 17. What's the third thing we look at? Yeah.
Reflection.
Reflection, yeah, what kind?
X-axis.
Yep, reflect over the x-axis. And the last thing. Yeah.
Shift down 4 units or shift up?
Yeah, one of those. Which one? Up or down?
Up.
Up. Okay, vertical is, it's not backwards. Plus is up, minus is down. So those are how you describe the 4 transformations to change this into that.
So what's the order? What's the order again?
Uh,
Horizontal shifts, then it goes vertical stretches, reflections, or vertical shifts.
Yeah, so the order is any horizontal shifts, any horizontal stretches, which we didn't have in this one,
Oh, okay.
then any horizontal reflections, which we also didn't have. To do a horizontal reflection, I would need that.
So you start inside and go out,
Yep.
and then you start from shifts to stretches.
Well, it depends which one you're doing. When you're doing inside, you start with the shifts and do the stretches. When you're outside, you do the stretches, then you do the shifts.
And then you end off with reflections.
Yeah, so horizontal shift, horizontal stretch, horizontal reflection, vertical stretch, vertical reflection, vertical shift. Those are the 6 in order. If you had all 6. This one only had 4 out of 6. All right, so this one we are looking for the domain. What would make it, well, what don't we want to do? Whenever you have a rational fraction, you need to make sure that you never, yeah,
Divide by 0.
never divide by 0. What would make it easier to see? What would make the denominator 0? Yeah.
Factor.
Yeah, let's factor it. How does the denominator factor?
X minus 3x plus 5.
Yeah, x minus 3, x plus 5. You can check it by going multiplying it out. We get x squared plus 5x minus 3x is 2x, and negative 3 times 5 is negative 15. Okay, so what values are we not allowed to use for x? Yep,
Negative 5 and 3.
negative 5 and 3. So the domain is all reals except negative 5 and 3. What happens at negative 5 on your graph? I know it's undefined, but I'm looking for a little more specific. Yeah?
There's a hole.
There's no hole at negative 5. Why do you think there would be a hole at negative 5?
Is there an asymptote?
There's an asymptote, yeah. So there's an asymptote at negative 5. What happens at 3? Yeah,
There's a whole,
there's a hole. Why?
because it's the same factor, x minus 3 and x minus 3 in the bottom.
Right, because there's a common factor with the 3. If you plug in 3, you don't just get 0 in the bottom, you get 0 in the top. That means it's a hole. All right, so now I want to write this in set notation. Remember, when you write it in set notation, you want to think of it in different pieces. How many pieces is it going to take, or how many intervals to write this in set notation. Yeah.
3.
Yeah, we're going to need 3. Can you describe the first piece for me?
Negative infinity, negative 5.
Perfect. That's the unbounded interval to the left, everything under negative 5. Or, Alexis, can you describe the interval in the middle?
Negative 5, colon 3.
And what kind of symbols?
Parenthesis, parenthesis.
Right, because we can't include negative 5 and we can't include 3. So that's the bounded interval in the middle. And then, how about the unbounded interval on the right? How do we describe that one? Yeah.
Alright.
Yeah, Jaden.
3 comma infinity.
Yep. And what else do we need there?
Parentheses.
Right. So there's 3 ways you can describe the domain. A sentence, a graph, and set notation. Yes.
Off the top of it, when would you use like the and or other way?
So and we don't really use when we're describing intervals because you can't have a number that's here and here at the same time. It could be here or here. So for when we're describing domain, we never would. Usually, when we're describing domain, instead of using and, we do something like this. Put the x in the middle, less than or equal to, 2 is less than or equal to x, which is less than or equal to 5.
So you use set.
Yeah, that we don't. A lot of times we don't use set notation with and.
Okay.
We write it as a compound inequality, and it's clearer. Yeah. All right. This one they want us to find a polynomial that has certain roots, and they've given us 4 and 1 plus 2i. But if we have 1 plus 2i, the conjugate always has to go with it. So if you've got 1 complex root, you automatically have 2. So these are your 3 roots. Because we have 3 roots, when we write the factors, how many factors am I going to have? How many sets of parentheses? Yep. Yeah, we're going to have 3. What would be my first parenthesis? Let's say that I could plug 4 into to get 0. Because this is a root, so I need something here that I could plug it into to get 0 as the answer.
X minus 4.
Okay. Now we have to follow that same pattern with these other 2. X minus my root. What would the second parenthesis be?
X minus in parentheses 1 plus 2.
X minus 1 plus 2i. And what would my last root be? Or my last factor, sorry. Yeah.
X minus condition 1 plus 2i.
Yep. Now it's just a matter of multiplying all that out. And that's going to be your answer. Which 2 do we want to multiply together first? It technically doesn't matter, but there's definitely 2 that if you do first, it's going to make this a lot easier. Yeah.
The imaginary.
Right. Do the imaginary first because that's going to cancel all the i's out. You're not going to be left with any i's if you do this right. We'll come back to the x minus 4 at the end. To multiply the 2 imaginaries out, what do I need to do first? Before I even start looking at both of them, yeah.
Distribute the negative.
Yeah, just distribute the negative. So you have x minus 1 minus 2i and x minus 1 plus 2i. Now we're going to distribute that out. Okay. So let's start by distributing x to everything. What's x times x?
X squared.
Yep, x squared. What's x times negative 1?
Minus x.
Minus x. And what's x times 2i? 2ix. Yep. All right, now let's do the negative 1. Negative 1 times x, negative x. Negative 1 times negative 1. And negative 1 times 2i. Okay, now we got one more. What's negative 2i times x?
Negative 2x.
Yep, negative 2ix. What's negative 2i times negative 1?
Just plus 2y.
Plus 2i. And what's negative 2i times positive 2i?
4i squared.
Negative 4i squared. And what's negative 4i squared?
Negative 4y.
Well, what's I squared?
Negative 1.
Negative 1. And what's negative 1 times negative 4? 4. So plus 4. So it looks bad right now, but it really, a lot of that's going to clean up. What's going to happen inside my parentheses?
The 2ix is going to cancel.
Yep, the positive 2ix and the negative 2ix is gone, so we don't have to worry about those.
And then 2i
Yep.
cancels.
The negative 2i and the positive 2i is gone. So now we're going to be left with a quadratic when we combine everything together. What do we get when we combine everything that's left in the parentheses? Yeah,
X squared minus 2x plus 5.
x squared minus 2x plus 5. Okay, so that was the hard part. Now it's actually a little bit easier. We just have to multiply these two together, but all the i's are gone now. Okay? And that, when I multiply them, that's my final answer. Okay, x times x squared,
X cubed.
x cubed. What's x times negative 2x?
Minus 2x.
Minus 2x squared. What's x times 5?
Plus 5x.
Plus 5x. And now negative 4 times x squared.
Minus 4x squared.
And negative 4 times negative 2x.
Minus 8x.
Plus 8x.
Oh, no, yeah, negative. Plus 8x.
And what's negative 4 times 5? Negative 4 times 5.
Minus 20.
Minus 20. Combine your like terms, and that's going to be our answer. So x cubed. What about the x squareds?
Minus 6x.
Minus 6 squared.
Yep. The x's.
Plus 13x. Minus 20.
Minus 20. So that is a polynomial that would have these three as roots. Now, the last type of question is to take this and figure out the roots. So do people want to see the last one, finding the roots? Yeah? Okay. Now I'm going to do the same problem. I'm going to reverse everything we just did, and hopefully we get these as the answers. All right, so now let's take this and go back. That's a cubic. Can I just plug it into quadratic formula to get my roots? No, it's not quadratic. So what's the strategy that we use to figure out some possible options for our rational roots?
Synthetic division.
We do need to use synthetic division, but right now I don't even know what number to try. Yeah?
4.
How would I don't know that though.
Well, because we skipped the, well, we technically do because the previous
Right, but yeah, we won't know that on the test.
C's and Q's.
Yeah, we got to do the p's and the
Oh, we
q's.
did.
P is all the factors of 20. What are all the factors of the number 20? We'll go low to high just to keep it simple.
Plus minus 1. Plus minus 2. Plus minus 4. plus minus 5. Plus minus 10.
10.
And plus minus 20.
Plus or minus 20. Ooh, a lot of options. How about Q? What are all the factors of my leading coefficient?
1, -1.
Just 1 and -1. So actually, that one came out nice. So if I take all the P's over all the Q's, it's just P's. So if this is going to cross the x-axis at a nice number, it has to cross at one of those 12 numbers. So I need to look between -20 and 20. And now at least I have an idea of where to look. Okay, it's got to be between -20 and 20. So let's graph that. So we've got x cubed minus 6x squared plus 13x minus 20. Okay, so let's set our window from -20 to 20, and hopefully it crosses at one of the numbers that's in that list. Right, so we got something. Where does it look like it crosses the x-axis?
Positive 4.
Positive 4. So we'll check it. Trace 4. Yep, it crosses at positive 4. So now when we start making our list of roots, we got a 4. Does it look like it crosses anywhere else? Then what does that mean about, I can look a little lower, you're not going to see it cross there, but if you want to look lower, you can. So what does that mean about the other two answers then?
They're imaginary.
They're going to be imaginary. This is the standard kind of cubic look when the other two answers are imaginary. So I've got that cubic. What do I do now with the 4? To turn the cubic into a quadratic. We're going to do synthetic division. Put the 4 on the outside. Put your cubic down. We got 1, -6, 13, and -20. Okay, so bring down the 1. 4 times 1 gives me 4. -6 and 4 gives me -2. 4 times -2. 13 plus -8. 5. And 4 times 5. 20. And add that column up. 0. So we already knew that 4 was going to be a root. We checked it on the calculator, so we're good. What do I use here to get my other 2 roots? Like what part of my answer do I need to use now?
All 3, the A, B, E, and C.
So what do you? So in the synthetic division, what are you looking at now?
Quotient.
The quotient. Yes, you're going to use the quotient, and you have to find your other 2 answers. So now, if it's factorable, we could try, but it's not going to be. So you said these were A, B, and C. What are you doing with that?
Quadratic formula.
Yeah, plug it into quadratic formula. So we're reversing everything we just did in the last problem. Okay. So quadratic formula, -b plus or minus the square root of b squared minus 4ac all over 2a. So 2 plus or minus, what's 4 times 1 times 5? 20. And 4 minus 20 gives me -16. 2 plus or minus, what's the square root of 16? -16.
4i.
4i. And what do you get if you divide 2 plus or minus 4i by 2?
1 plus or minus 2.
1 plus or minus 2i, and 4 are my roots. And if we go back up, that's exactly what we studied. So we did a full circle with that. Started with the roots, found the polynomial, took the polynomial, changed it back to the roots. That covers that as well.